This is for Year 9 Maths, so we're going to look at the advanced section of the problem-solving task. Now, in the past two sections, we tried to check whether if we, for a right angle triangle, whether if we draw equilateral triangles along the sides, whether that area plus that area is equal to that area. And you should find that it's roughly true, okay? You might be a bit off, and that's okay, because the only reason why that is you would have measured using a ruler, which isn't completely accurate. But if it's roughly the same, then we can say that those areas do equal. Now, we're going to extend our understanding to see, for a right angle triangle, do semicircles work? So if I drew semicircles along here, does the yellow added together equal the blue? Now, the formula for a semicircle, is pi times r squared, and you divide the whole thing by 2. So, before we go into using the formula, we need to know what r represents. R actually represents the radius. Okay, so if I draw a circle here, and we have the center of the circle, if I extend a length from the circumference of the circle, then going to the middle, then going to the circumference again, this is known as the diameter of the circle. Okay. Now the radius of a circle is actually half of the diameter, because the radius of a circle is the distance from the center of the circle to the outside of the circle. So you can think of it as like a hand on a clock. Okay, so if it goes from the center to the outside, then this is known as a radius. Now, we're not dealing with full circles, we're actually dealing with semicircles, which is why there's a divide by 2 in the formula. Okay, so the area of a circle normally would actually be pi times r squared, but because we only have half a circle, we're doing the divide by 2. Now, let's go back to the triangle. If I were to draw a semicircle here, my side length is actually the diameter. So in order to use the formula properly, you're not using the whole diameter, you're using only half of it because you want the radius. So you're just using half of the length. So let's give an example. They've given you a right angle triangle where you have sides A and B equaling 1, and you need to find the hypotenuse of C. Okay, that's pretty simple, because I know that the hypotenuse side is given by, or C is given by, the square root of 1 squared plus 1 squared. 1 squared is 1, 1 plus 1 squared is another 1, 1 plus 1 is 2, so that's the square root of 2, which equals 1.141 on the calculator. So this side length would equal 1.414. So 1.414 centimeters. Okay, now my task is, I want to draw semicircles around these sides, because I want to check whether this semicircle plus that semicircle equals that semicircle, equals the semicircle of the longer side. Okay, how do I actually use the formula? So on your calculator or on your paper, this is what you're going to do. You're going to go area equals pi times r squared divided by 2. Okay, pi is actually just a number on the calculator, okay? So on your calculator, you should, I don't actually have the calculator you have, so I'm going to use my one. Okay, this is a calculator you're going to use in Year 10. I actually have a pi button. Your pi button, I think, is when you click shift, and it's somewhere near there. It's actually on top. You have to click shift and another button to access it. So just look around for where the pi button is. Remember, to access it, you need to press shift, then that button. Okay, and then you've got to go times. Now, what's my r? Because we want to calculate r squared, but we don't have r. Now, remember what I said? If I want to calculate the area of this semicircle, the r value is actually not this whole length. This whole length is 1. It's actually half of it, because we want the radius, not the diameter. So we want this one. We don't want that one. So we've got a diameter here of 1. So the radius is half of that, which is 0.5. Okay, 0.5. And we're trying to square it. So we're going to go pi times 0.5 squared, and then divide by 2. So on the calculator, you're literally going to go pi times 0.5 to the power 2, and then I'm going to divide everything by 2. So that's literally what you need to enter on your calculator. And I get 0.3927. Okay, so 0.3927. 0.3927. I know my area of the shorter side will be 0.3927. I don't need to calculate the area of this one because I know it's exactly the same as this one in this case. It's not always the case, but in this case it is. Now, for the third side, the longer side, the hypotenuse side, how do I calculate the area of the semicircle? Again, if I draw the semicircle, we've got 1.414. The area is given by pi times r squared. Now, what's my r value? That's the diameter. So the r value is 1.414 divided by 2. So it's 0.707. So 0.707 squared divided by 2. And you can calculate what that area is. Let's check. So I got pi times 0.707 squared divided by 2. And I get 0.7852. 0.7852. Now let's do a check. Does these two areas add together, give you roughly this area? Okay, let's double check. Let's check that. Let's see what 0.3927 plus 0.3927. 0.7854. Okay, really close. So we may have some errors in our rounding, but essentially when you add these two areas together, we get that area. So does Pythagoras work for semicircles? I'll leave that to you to answer. Hopefully that helps.